Hello, I'm Michelle Davis with the Center for Manufacturing Research at Tennessee Tech University in Cookeville, Tennessee. Welcome to the Fall 2018 Golden Eagle Additively Innovative Virtual Lecture Series. This is the sixth semester we have produced this popular and informative series. This series is hosted by TTU's Center for Manufacturing Research and the iMaker Space at TTU. The CMR is recognized as an accomplished center of excellence that draws together resources of the state of Tennessee, the university, industries, and government funding agencies into a cooperative effort to be on the leading edge of the latest technological advances in the manufacturing field. The iMaker Space, located in the Volpe Library on Tennessee Tech's campus, has a goal of providing an interactive and collaborative space for students and faculty to use in pursuit of innovative and entrepreneurial projects. Additive manufacturing is the focus of both entities, and as such, this short virtual lecture series has been planned to highlight the best practices, potential problems, technological advancements, innovations, and scientific contributions in additive manufacturing, with expert talks from various institutions, industries, R&D centers, and laboratories. Today, we are honored to hear from Tom Singer, Professor of Mechanical Engineering Technology and manager of the STEM Guitar Laboratory at Sinclair Community College in Dayton, Ohio. His talk is entitled, Integrating Additive Manufacturing into CAD Design Classes. We request that you mute your microphones and phones during this presentation for the most optimal experience. The speaker will provide his contact information for questions after the presentation is over. Thank you, and I now turn the presentation over to Tom.
Thank you, Michelle. I just wanted to make sure that my audio is okay.
Yes.
All right. So welcome, everybody. My name is Tom Singer, as Michelle indicated. I am a co-PI also on the AM Watch project, and today we're going to be talking about how to bring additive into a CAD design environment. And so additive starts with CAD, and so the whole process of being able to make parts and objects, whether they're prototypes or an additive final part, it all begins in the CAD environment. So the key is that it really doesn't matter which CAD 3D model solids program you choose. However, there are some things that you want to look for in your selection process. First, you want to choose one that has a good level of accuracy. So there are some CAD solid modeling programs that are out there that are primarily a push-pull style, which don't provide a high level of accuracy. You may want to steer clear from those.
Hey, yo, gang, I'm gonna get extra.
You may want to steer clear from those, as they'll make it more difficult to be accurate in your actual designs. You also want to make sure that you have a format that is recognized by most of the 3D printer manufacturers. Today, the most common output format is STL. However, DXF is also used in processing some of the file developments. The next generation format is an AMF format, and if you want to learn more about the AMF format, which isn't necessarily a standard today, but look for that to begin in the near future, you can go ahead and look up ASTM F42 solid modeling standards. And so the next gen of our 3D modeling environment will be managed through this AMF format. So in an educational environment, you're typically challenged with financial constraints and equipment. And so you want to make sure that you choose a CAD program that your systems can support, but don't necessarily go by the minimum requirements that are specified by the manufacturers that you're looking the software manufacturers that you're looking to use. In most cases, a slightly lower level of minimum level of computing power can be used. I have found that laptop computers can be significantly lower to be able to drive CAD software. However, if you're using a desktop style computer, having a separate graphics card really does make a huge difference in the capability and use of that software environment. So be aware that you do have some flexibility with your choices. And also select a CAD tool that's nationally and regionally used. Right now, SolidWorks is probably one of the most widely used 3D-based CAD software packages that's available. Unfortunately, it's not free to most schools. Only a limited number of schools do get the free software from SolidWorks. So you have to weigh that versus cost versus use when you're looking at that. However, there are several free CAD software packages that are free as enterprise level tools that you're able to use in your classroom and personally along with your students. And that includes Onshape. And Onshape is actually a great tool that is developed by some ex-SolidWorks developers. And so that works really well at all levels, basically from middle school through collegiate level. Autodesk Fusion and Autodesk Inventor. Fusion is the newer product. Inventor is the existing 3D modeler. Again, both of those are free to an enterprise and personally for educators and students. Tinkercad, great tool to use for middle school and high school students. It's a little bit simpler to use. It does use push-pull technology, but there's a high level of accuracy in the Tinkercad environment, so you can actually control the size of your parts. And then Sculptress, if you want another free tool that's great for creating sculpture style where it is truly a push-pull environment, it is a great free tool that you're able to use in your design development. So the upfront aspect of the CAD modeling, it's a choice that you're going to need to make and look at your advisory committees and the region that you're working in, along with your budget, because that always drives your selection process. And so I recommend that you try to start your modeling process early in your class. And so typically in just a few weeks, you want to get your students involved in the basic operations of how to create 3D solid models. So initially you want to cover the basics of what the design process is, and this gives them the foundation to develop their models accurately. And so they follow a plan, and then they can go through the refinement of that overall process. It's a continuous improvement environment. Visualization skills. I find that some students are really good with visualization, others have a challenge at it. And believe it or not, video games is a great way to gain that visualization. Now that doesn't mean that the professor gives you authorization to just go out and have a binge on 3D modeling for playing games. However, it does enhance your spatial relationship in the development of your three-dimensional skills as you continue to interpret the environments that you're using within the 3D gaming environment. Jump into 3D modeling and 3D printer operations soon after that. And so as you get finished with sketching, jumping into the 3D modeling tools, early on start to create some very simple parts that the students can actually send to the printer and model. The students will get captured by the ability to create an actual object that they have designed or that they have customized. And so getting that in their hands really cements this process of learning for them. I also use this as an incentive within my classes. So the students really do want that hands-on learning. However, there's a lot of topics within the CAD design courses or course materials that aren't as attractive, such as geometric dimensioning and tolerancing, or dimensioning and documentation of prints, fits and tolerances. And so these are topics that are not as attractive to students in the term of the learning environment, but they are a way that you can incentivize in terms of making parts and talking about how the parts fit together, or why don't they fit together, or what type of fit it might be, or how do we apply geometric dimensioning and tolerancing principles on parts that we're creating. And so one of the exercises that I typically do is I have student teams create different fits. And then we talk about how and why the parts may or may not fit in terms of how they designed it versus what actually gets printed. And there is a difference because you have material shrinkage. And one of the interesting aspects here we go. Sorry about that. One of the interesting aspects is that you can print several 1-inch cubes or a 3-centimeter cube on your 3D printer and make it solid. And the idea behind this is to determine how your 3D printer actually creates a part. And a simple 1-inch cube will then allow you to determine the level of accuracy that your 3D printer has. So when you do start to talk about fits and tolerances, your students then have an idea of how they can develop their parts, because it may be more accurate in the XY direction than the Z direction. That's personally what I've found, that the Z direction built on fused deposition modeling, the FDM machines, as I've shown here in my presentation, typically have a variation in the Z direction, but that isn't always the case. So you need to create the 1-inch cubes on your machine, have your students use some calipers to measure and mark the top, front, and side of the cube as it comes off of the plate to determine how your machine works with its accuracy environment. And there is a deviation on the printing direction, as I mentioned, plus the type of material, ABS versus PLA. Both will have different shrinkage rates as they cool. So the key is you want to mark those tops and sides for your level of accuracy. And then employ this process as you design solutions and parts. So the students do actually want to own their designs. So having a situation where the students actually create some of their own unique parts, not just grabbing tools or objects from Thingiverse and printing those. That's an inspirational website that you can utilize. But this is an aspect where you want the students to actually own that component that they're creating. And so you could also partner and provide a unique experience. We've been involved here at Sinclair since 1997, 96 with 3D printing and prototyping. And so early on, we discovered the ability to do this collaborative development environment. And so over the years, we have had experiences for our students to collaboratively work together on developing parts. So this semester, Dr. Fadan and myself, and also our students are going to be partnering together as we develop parts as we go forward to design a solution. In this case, we're going to be developing a solution for patients that have had carpal tunnel surgery or have very weak wrists to be able to open pressurized bottles, whether they're a 2-liter, 20-ounce bottle. But being able to turn that cap may not be an easy task. So our students are going to develop a design solution. And Tennessee Tech students are going to test the solution for both strength and accuracy and product viability, and then we'll come back and continually collaborate on the design process as we go. And so coming up with product solutions to problems is a great way to get your students to buy in on the design itself. And so be aware that there are a lot of opportunities, or have your students come up with that opportunity as part of that operating environment. You can use Thingiverse, and Thingiverse is a great sharing tool. And the way that I'm using Thingiverse now with our students is that as they design new and unique components, I ask them to upload it to Thingiverse as part of their class. And the concept is that the students can use this as a great resume builder, because now they've got a part that is out on the web that they can point to that they've designed, whether as part of a team or individually, that's now posted as a free download within the Thingiverse environment. So in this case, it's way cooler than just hanging a picture on a refrigerator like we used to do to show off our work. This is a way that your students can typically show their work off in a much larger format environment. So additive manufacturing, and you might have heard that I've been using two different terms in terms of prototyping and then additive manufacturing. And so prototyping is the ability to use like fused deposition modelers to create a prototype concept. Additive manufacturing is where we create parts that are actually going to be in use in a production environment. And so this industry is starting to explode across the United States and the world primarily. And so one of the aspects of our AM Watch project is to develop the structure for the technician environment. And so what do technicians need to have to be an additive manufacturing technician? And so there are a variety of different skill sets and that we're looking at as part of our project, the skill sets and how those skill sets and what skill sets are needed. And we'll be posting that up on the AM Watch website so that way we're able to share those skills as we move forward, as we develop this list. And it's not an exhaustive list. There's both soft skills and hard skills that need to be applied to be a good technical specialist for additive manufacturing. There's a huge leap though between the ability to do the foundational prototyping environment and the additive metals. The design for additive metals is truly a next step. And so there's a variety of different things that you can prepare your students with to get ready for the additive metals. Currently, most community colleges and many universities just do not have the resources to have an additive metals machine. They're just cost prohibitive unless they get access through a special project or partner with an industry locally that has a machine or a bank of machines. And so again, accessibility is limited, but we can still work to train our students and develop additive manufacturing technicians. And so how can you position yourself? Whoop, did I go too far? No, that is the next one. So how can you position yourself to get started? And so in the additive manufacturing side, you'll want to focus on started with the prototype side. So you can start with sub $500 3D printers. The one that's shown here to the right is one that our AM Watch project has standardized on. It's termed a monoprice printer, and there's different levels and different models. It's a low-cost printer. It's actually under $300 to get started. So be aware that your entry-level costs are not cost prohibitive. You don't have to go out and buy a multi-$1,000 machine just to get into the prototyping game. Instruct on the additive processes. So don't, as part of the additive environment, don't discount the concept of talking about the different materials, both on the prototyping side and on the additive manufacturing. Every few weeks, there's brand new metal materials that are being developed, different derivations of the materials that are currently out there. But being able to speak to a variety of different material choices is an important aspect for an additive manufacturing technician to be aware of and how those materials will work. Learn from your part failures. Why did the part fail? So was it a situation that it was a failure in the design process? Did it not have enough support? Was there a bonding issue with the PLA or ABS? Was your ABS or PLA having a high moisture content? And that is one of the critical components of failure within the within the PLA and ABS is moisture. And so you need to keep your material as dry as possible. Don't leave it without being in a protective environment. And that does make a difference in the quality of your prints. Make sure that you have your students do the setup and the running of the machine. Initially, I train my classes in how to do this. And so each student has an opportunity to do the setup and operation of the machine, because we run a fair amount of parts in our classroom environment. And so you can create a verification process or a checkoff process to allow your students to run the machines once they're accurately trained and can replicate that particular process. And so some of you have powder 3D printers. We actually have a powder 3D printer that was a Generation 1 powder 3D printer. The key thing is that you can still utilize that technology and talk more about the additive manufacturing side, the metal side, because the similar technology of what is used in the powder is what's used in the additive metal side. You still use a powder-based sweep process in many of the 3D additive manufacturing metals printers. And so keeping that technology around is definitely a benefit to begin that training process. We use non-functioning 3D printers as a training device. And so as we're bringing our technician certificate program online, one of the classes is going to get into the maintenance aspect of 3D printers. And so any 3D printers that are limited functioning or non-functioning are going to become tools to use to disassemble and reassemble. And one of the tasks is that one student team is going to have to document how to disassemble a machine, and then using those notes from that team, another team of students has to reassemble the machine based on those notes. And so this is a really good way to introduce that technical documentation and writing into a technical curriculum, but it also covers about how to document a series of processes. And it gets down to a really fun level for the students, because again, it's a hands-on learning environment. They all have cameras with their phones, and using that technology to document each step that they're able to do, and then write whatever instructions associated with that step to apply to that photograph. So how else can you generate additional knowledge? And one of the opportunities is to attend one of the AM Watch studio training opportunities. So each year our project offers 1 to 2 training opportunities throughout this country. And so this year in 2019 we'll be hosting a training studio here at Sinclair Community College. Our dates are to be determined currently, but it will be sometime in 2019. Here, this happens to be a photograph of our training event that was held at the University of Louisville just last December. So again, sub $300 printers are usable and a great entry point. $600 to $700 printers, 3D printers, have more stable operation, both hardware and software. Look for things like heated adjustable beds or plates, variable temperature control so you're able to run multiple materials. Having an enclosed operating environment is more stable. It keeps temperatures more stable, and it allows for a lack of drafts. It's amazing at how much just the air conditioning draft on a 3D printer can cause the material to harden too quickly and not bind properly. But also invest in decent PLA material. And so one of the recommendations is always start off with the PLA because it's easy to use. Plus it's quite low cost. And there's a variety of different PLA tools that are out there. And so plan on spending about $20 a spool. There's some that are less than that. But again, if you want to buy one and test it out, that's great. Also be aware that the color of the material does cause changes in how it melts and flows, because the coloring process is slightly different. So you might have better luck with specific colors. And experiment. So don't invest a lot of money in a lot of material initially. Experiment with some spools, find out what works the best for your printer, and then secure multiple spools once you have determined that. There's some fantastic unique materials out there. We use a flexible PLA material, works great. We also have used the wood material. There's actually a wood infused PLA, and you can sand it and it looks and feels very similar to wood. It will accept stain because it is basically bound wood fibers with the PLA. And there's also carbon fiber threaded PLA. There's a variety of different fiberglass and carbon fiber threaded PLA. So there's a variety of different materials that you can experiment with in your designs. And one of my tips is that to keep your desiccant packets for storage of the unused materials. ABS and PLA are both moisture sensitive, ABS more so than the PLA. By the way, PLA is also not UV resistant, so don't stick it in the window. It will degrade the build. And so, again, things that you typically discard are tools that you can use. So keep your packets in large Ziploc bags with a desiccant packet inside to help keep that moisture level down until you're ready to use. And so as we come to the end, you can send any questions or comments or information to my email address. And email is by far the best way to get a hold of me. You're welcome to track down my phone number. It is available. It's up on the web. However, you'll get a faster response through email in this environment. So I want to thank you today for having me speak a little bit about integrating 3D CAD and additive manufacturing and prototyping, and be aware that this particular industry is one that is really going to blossom and change the way that manufacturing is done as we move forward. Have a great day. Thank you.